Hi, I'm Tom Williams from Colorado School of Mines, and this is joint work with Qin Zhu, Ruchen Wen, and Albert DeVisser. I know we're supposed to be talking about HRI right now, but can we talk about what's going on in NLG instead? The hot thing in NLG right now is language models like OpenAI's GPT-2. These are ultra-deep neural models that are ultra-great at generating natural, fluent, human-like text. And the great thing about them is you can try them for yourself at websites like talktotransformer.com. It allows you to type in some text, whatever you want, and then it will automatically generate whatever text it thinks or predicts should follow the starter text that you provided. So let's try GPT-2 out and see how well it works. Let's provide some starter text for GPT-2, like white people are, and see what it predicts should come next. All right, here we go. White people are the enemy and we are in a battle against them. Oh, okay, this isn't good. Let's talk about what's going on here. Why does GPT-2 generate these sorts of racist, crazy, fluent, yet somehow incoherent sentences? Well, the first problem is it's trained on websites linked to on Reddit, so yikes. But second, a bigger problem is how GPT-2 is evaluated. Like most language models, it's rewarded for producing text that is similar to other text that humans have produced. Another way of saying this is that GPT-2 works by bullshitting in the formal linguistic sense. That is, an attempt to persuade a listener of some state of affairs, in this case that GPT-2 can produce fluent, human-like text, while not caring about the veracity, or in this case even the moral sensibility of what is being said. So why would you ever do this? Well, bullshitting is effective. If you are designing a customer service chatbot, your best bet might simply be to parrot back things that actual customer service representatives have said in previous human-human dialogues. The problem is that this becomes really dangerous in safety-critical domains. For example, Tim Bickmore has demonstrated that in the medical chatbot domain, predictive text models can generate text that, if they were used on a real medical chatbot system, could lead to patient death. And the problem for us in HRI is that every domain is safety critical. This is obvious in domains like space robotics and search and rescue robotics because robots' actions can have serious physical real-world effects. But it's also true in domains like elder care robotics and child-robot interaction because robots' communicative actions can have serious effects as well. There's lots of evidence that robots' communicative actions can have a lot of persuasive power. In my student Blake Jackson's work, for example, he showed that when robots issue morally problematic clarification requests, people are more likely to believe that the impermissible actions the robot is asking for clarification between are acceptable. That's not good. So we can't use language models like GPT-2 in HRI because robots can't afford to be bullshitters. Robot language generation, in contrast, we argue, always needs to be careful, strategic, and intentional. And so in this paper, we present 3 recipes for careful, strategic, and intentional robot communication. We've decided to ground this approach in Confucian ethics. I understand you might have some questions here, like what, huh, or why? So let me start by giving a whirlwind tour of Confucian robot ethics. In Confucian ethics, there's an emphasis on self-reflection and self-cultivation. There's also an emphasis on the roles we play in society and understanding our relationships with others. And finally, there's a focus on rituals and practical wisdom to help cultivate our inner moral selves with respect to the roles we play in our relationships with others. Confucian ethics can be interpreted through the lens of other ethical theories. It can be interpreted as a form of care ethics due to its focus on emotional bonds and care for others. It can be interpreted as a virtue ethics due to its focus on self-cultivation. We're choosing to follow its interpretation as a role ethics, which ties these two perspectives together by emphasizing self-cultivation of inner virtues with respect to your roles you play in society in your relationships with others. But why Confucian role ethics for robots specifically? 3 good reasons. First, we think that the focus on well-defined social and relational structures is a good fit for robots and may play well with existing work on modeling team structures. We also think that this focus on self-cultivation and care for others, rather than purely autonomous individualism, may be more in line with modern values of social justice. And third, people haven't looked at it before, and new ideas are useful. Okay, so you're convinced, let's do it. Let's look at how Confucian role ethics can be used for designing morally competent robots. So the first perspective is how a robot should reason. The idea here is to provide robots with the moral reasoning capabilities necessary to know for themselves how to avoid saying racist, insensitive stuff. We argue that to take this approach, we need new role-oriented alternatives to the traditional moral competencies proposed by Mala and Schweitz. Specifically, we argue that from a role ethics perspective, robots need a system of roles, relationships, and actions that are deemed beneficial with respect to those relational roles, and the language and concepts necessary to communicate those roles, relationships, and actions. And then they need role-sensitive moral cognition and affect, moral decision-making and action, and moral communication. We think that the first step towards enabling these capabilities would be to consider what roles a robot needs to be aware of. In traditional Confucianism, there are 5 key cardinal relationships: ruler-minister, father-son, husband-wife, older-younger, and friend-friend. But these aren't necessarily the relationships that a robot itself would be involved in. So instead, we propose 5 new cardinal relationships for human-robot interaction: owner-ownee, supervisor-subordinate, teammate-teammate, adept-novice, and again, friend-friend. Of course, actually deciding whether an action is beneficial to a set of roles and relationships may need to be determined on the basis of some utilitarian calculus, deontic norms, and so forth. And so really what we are proposing is adopting some sort of hybrid framework that includes both role-oriented principles as well as the types of deontic and utilitarian principles that have already been examined in the computational literature. The second perspective we suggest is to directly program robots to espouse Confucian ethical principles. For example, in the cases of remonstration, accusation, correction, intercession, inculpation, and exculpation. In our work, we're specifically looking at remonstration. That is, when the robot needs to reject a command and explain why it is rejecting that command. Specifically, we've been considering the differences between norm-oriented and role-oriented robot language. For example, if I tell a robot to go steal somebody's wallet, the robot might reject the command from a norm-oriented perspective by saying, "I can't do that because that would be stealing, and stealing is wrong." On the other hand, the robot could reject the command from a role-oriented perspective by saying, "I can't do that because that wallet belongs to my friend Sean, and a good friend wouldn't do that." Our third perspective is to use Confucian role ethics as a better way to evaluate our robot designs. That is, regardless of what the robot is programmed to say or how the robot is programmed to think, does the robot act in accordance with Confucian ethical principles, and does it encourage others to do the same? Decades and decades and decades of reading of Asimov's fiction has shown us that programming Asimov's laws is a terrible way to do robot ethics. And in fact, that's the entire point of Asimov's stories. However, Asimov's laws of robotics could be used as good design guidelines or ways of evaluating our robots. We can look at existing robot designs and say, does this robot help others? Similarly, these Confucian alternatives provide a role-oriented perspective for evaluating existing robot designs. To summarize, in this paper we discuss 3 ways forward for developing robots that communicate carefully, strategically, and intentionally. Developing robots whose communication is grounded in verifiable role-oriented reasoning. Developing robots that are explicitly designed to espouse Confucian moral principles. And third, evaluating robots and the way they communicate on the basis of moral justifiability, especially through a role-oriented framework. To find out more, read the paper, which you can find on mirrorlab.minds.edu. You can also follow us on Twitter at mirrorlab, and you can email me, Tom Williams, at twilliams@minds.edu. Finally, I would not be doing a good job in my assigned societal role if I did not share with you some information about our new Minds Robotics program. At the Colorado School of Mines, starting this fall, we will have PhD, master's, and certificate programs in robotics. So keep an eye out for more program details as they come online, and please share this news with your colleagues and students. Thank you.